Hello, students. Today we are going to work on Unit 3, Day 8, Constructing an Angle Bisector. So if you are in your notes right now, which hopefully you are going to turn to the page that says Day 8, which is page 17. You are going to need a compass and a ruler, so if you don't already have one, get one. Just like a moving buddy in Toy Story. If you don't have one, get one. I've watched too many Pixar movies. All right, so first thing is you got to know what an angle bisector is. So an angle bisector obviously has something to do with angles, and bisect, remember, means cut in half. So an angle bisector cuts an angle in half. In fact, it is a ray or a line passing through the vertex of an angle, splitting it into two equal parts. A ray or a line passing through the vertex of an angle, splitting it into two equal parts. So if we look at this angle that's off to the right here, if I want to cut that angle in half, I would need another line right here that comes through so that this little piece is equal to that little piece, and each of the pieces is half of the whole thing. The good news for us is the construction by which we do that is a pretty simple one. We don't even have to change our compass. We set it at one stage, and then we usually do not have to change it. So if I want to construct the angle bisectors for each of the following angles, the first thing I'm going to do is you're going to grab your compass, and you are going to open your compass to really just a comfortable opening. So you're going to put the pokey part of your compass on the vertex, and you're going to open your compass, I usually tell people, halfway, 2/3 of the way down the first edge of your angle, down the side of the angle. All you're really doing is opening it in a way that's comfortable for you to swing an arc. So you're going to open this and just draw a big arc. Okay? Then, after you draw that arc, you're not going to change your compass setting at all. You're going to move the pokey part of your compass. I just have to rotate mine. I'm going to move the pokey part of the compass up to one of those intersections and draw another arc toward the middle of the angle. Then move your pokey part to the other intersection, draw another arc toward the middle of the angle. Those two things should intersect, and then you are going to draw a ray out from your vertex through that intersection, and you have made an angle bisector. Okay. Now, if you're thinking, why does that make an angle bisector? Well, what we really do is when we first draw that arc, what we're doing is we're finding 2 points that are equidistant from the vertex. So we're kind of like measuring the width a certain distance out from the vertex. And then, if you think about it, you don't need to draw this, but if you think about it, if I were to draw a line connecting those 2 points and then draw 2 arcs above it like this, I've started creating a perpendicular bisector. So what's really happening here is your angle bisector is the perpendicular bisector of that invisible yellow line that I connected. Now, all that yellow stuff you really don't need, so if I make it all disappear, you can forget about everything I just said and remember how to draw an angle bisector, but I want you to understand that an angle bisector actually gets its roots from that perpendicular bisector we did a while ago. All right, now we're going to do it again on this obtuse angle. So I'm going to take my compass. I'm going to open it a comfortable width. Yeah, that looks pretty good. Put the pokey part on the vertex. Put the pencil a comfortable width down the line. Draw an arc. Then I'm going to move my pokey part to one of those intersections. Draw an arc toward the middle. Move my pokey part to the other intersection. Draw an arc that hits the one I just drew. And then draw a ray out. Vertex through there. Da-da-da. Now, there's a bunch of stuff we can do with angle bisectors, and that's what we're going to do next. So this one says, construct an equilateral triangle, then construct a 30-degree angle. Well, why would I have you do both of those? So let's think it through. An equilateral triangle is a triangle with all equal sides and all equal angles. And if I have three equal angles that all add up to 180, an equilateral triangle would have all 60-degree angles. And if I want to take a 60-degree angle and make a 30-degree angle, 30 is half of 60. So we're going to make an equilateral triangle and then cut one of the angles in half. Perfect, we can do that. So I am going to grab my compass again and think about how we made an equilateral. So to make an equilateral, that's where we opened it the entire width of the line and said, okay, I want three sides with a length of AB. So I'm going to draw one arc up, draw another arc so that it hits the first one, and then connect the end points to there. That and that. So now I have a perfect equilateral triangle, and if I want a 30-degree angle, I just need to bisect one of those angles. So let's bisect angle B. So I'm going to open my width of my compass comfortably, draw an arc on angle B, move the pokey part to one intersection, draw an arc toward the middle, move my pokey part to the other intersection, draw another arc, and then bisect angle B. So this is a 60-degree angle, this is a 60-degree angle, and I split this one in half, so those are both 30. And fun fact, I've accidentally also made another angle. 30 plus 60 is 90. 90 plus 90 more is 180. I've also made a right angle using no protractor at all. All right, turn the page. Construct a perpendicular line 2M through point P, and then construct a 45-degree angle. All right, so perpendicular line through P. Well, let's see. That was one of those other constructions that we did. Perpendicular through a point not on the line. That's the one where we kind of need to fake a perpendicular bisector. So I'm going to open this so that it hits this bottom line twice. Then I'm basically going to find the perpendicular bisector of this new segment I just created. So now I am going to open my compass more than halfway, which it is already, and make my football in between those two intersections. And then if I draw a line through those intersections, it should also pass through P. Fantastic. I've now made a perpendicular to M through P. Then construct a 45. Well, a perpendicular line makes a 90-degree angle. So if I want a 45-degree angle, I just got to cut that in half. So let's see. Let's do orange to make it a little bit more obvious. So I want to cut this 90-degree angle in half. Well, I'm going to open my compass a comfortable amount. I am going to draw an arc that hits both sides of that 90-degree angle. Go to one intersection, draw an arc through the middle. Go to the other intersection, draw an arc through the middle. And then connect a ray from the angle's vertex through the intersection. That has now made two 45-degree angles. Now, the last stuff we're doing, we don't need a compass for at all. It's just make sure that what you know that bisect means cut in half, and also means that you get two equal parts. So now we can just do some of this with the numbers and say each figure shows a triangle with one of its angles bisected. The bisecting angles are marked as 1 and 2. All right, fine. So if 1 and 2 were bisected angles, that means 1 has to equal 2. Those little single arcs I drew mean that they are congruent. So if angle 1 is 6x minus 1, okay, so this is 6x minus 1, and RTS, well, RTS is the whole thing, is 10x plus 4, Oops, green, I said green. 10x plus 4, solve for x. Well, if 6x minus 1 is angle 1, then angle 2 could also be 6x minus 1 because they're equal, and 1 plus 2 has to equal the entire thing. Another way to think about this is pretend I didn't even write in what angle 2 was, since I know that 1 is half of the entire thing. That means 6x minus 1 equals 5x plus 2. 6x minus 1, is half of this. Half of 10x plus 4 is 5x plus 2. Or I could say double 6x minus 1 equals 10x plus 4. All of those are equivalent equations, and you can use any one of those that you want. Okay, any single one that you want. I'm going to use the one on the bottom just because then I can write underneath it, but you can pick any one you want. All three of these are equivalent. And now I'm just going to solve for x. So I'm going to distribute my 2. 12x minus 2 equals 10x plus 4. I'm going to subtract 10x. I'm going to add 2. And then divide by 2. We got x equals 3. And then what did the question say? It just said find x. So we found x. X is 3. And if I go back and see if that makes sense, if 1, okay, if angle 1 here was 6x minus 1 and x is 3, 6 times 3 minus 1 is 17. The whole thing was 10x plus 4. 10 times 3 plus 4 is 34. 34 to 17, it got cut in half. So I am convinced that my answer is correct. Last one. Down here we got angles 1 and 2. This is the angle bisector. So 1 has to equal 2. Pardon me. Angle 1 is 5x minus 2. Angle 2 is 4x plus 4. They're supposed to be equal, so I'm going to set them equal. If that's an angle bisector, the two parts created are equal to each other. And then I just solve for x. Subtract 4x. X minus 2 equals 4. Add 2. And I get x equals 6. See if I can convince myself that I'm right. If x equals 6, 5 times 6 minus 2 would be 28. 4 times 6 is 24. Plus 4 is also 28. Yep, I am feeling pretty good. Alrighty, that is that, my friends. So what I would like you to do is practice the homework for day 8 in your homework packet. So homework for day 8 in your homework packet, and we will work again soon. I hope you are having a great day and continue to have one. Talk to you soon.